This is Unit 1 presentation for Math 2130 with Molly Andrejcak. For number 1A, it would be perimeter because it is calculating all of the outside edges. And all you have to do for that is add together whatever is given. And since it looks like a square, it should be it should be the same amount for each side just because they are equal. For 1B, it is one-dimensional just because we only were told about the length. If we were told about the length and the width, I believe it was two-dimensional, and three-dimensional is length times width times height. But since the question had only given us the length, it would be one-dimensional. For 1C, a non-standard unit that could be used to measure the length of the ribbon could be the thumb tip trick, which is actually going to be from the center of your thumb all the way up to your tip of your finger. The trick is to be able to measure an inch. So I guess when we take our thumb and put it up against the ribbon, we can get how many inches the ribbon will be and convert it to whatever we need to. For 1D, the volume is determined by what can fit inside the box. So if we were to take this, we could see what fits in, and for my non-standard, I chose sugar cubes just because they are almost all they're about the same. They have the same volume and things like that, and the same perimeter, but they could each fit in and pile in inside this box, and it should be equal. For 2A, let's see. For 2A, or actually 2B, sorry, we had to draw the net, which a net is basically a three-dimensional figure flattened. So I drew it 3D just to get a little, just to see it, so I could draw it. But the description had given us that the length was 14 inches, the width was 8 inches, and the height was 4 inches. Let's see. So in order to find this, again, I used this. So our length would be the long side, our width would be how much it goes back, and our height would be how much it goes up. So right here is our net. I knew that our length would be 14, so throughout the whole net, it would be 14. Not smaller than that, but just 14. Right here, as you can see, all the way down. Our two flaps right here would indicate the sides, our little rectangles on the sides, which is 8 and 4. The height is 4, and then the width is 8. And let's see. For 2B, we wanted to know how much it would cover. So I found the surface area, and by finding the surface area, I have shown over here. The surface area is all of the areas added together in order to make something squared. So right here, I did 8 times 4, which got me 32, and I knew that these two were the same. And then I had done 4 times 14 in this in this rectangle to get me 56, and I knew that these two were the same, so I just plopped it right there. And then I knew that these two were also going to be same, and 8 times 14 is 112, so that's where I got the 112s from. And then again, for 2B, I added 32, 32, 56, 112, 56, and 112 all together to get 400 inches squared. Now, the surface area and the area are going to be squared. The perimeter will just be its own metric unit. So if it was perimeter, it would just be inches, but since this is surface area, it is inches squared. And then we'll get to volume because that's a different situation, and we'll be finding that. But let's see. For 2C, I got the volume to be 448. This is supposed to be inches cubed. Sorry. But in the description, there was something called the layers idea. What I thought it was is the height. So what I did was I found the area, which is length times width, and I knew that the length was 14 and the width was 8, so I got 112, which happened to be these two squares. Then I knew that volume was length times width and then times height. So since I already found the length and the width to be 112, I did 112 times 4 to get 448 inches cubed. The layer idea is the height. So if I were to fold this up and make it, I guess, into a solid, it would be 4 layers high. So that is where I got the layer. That's what I figured out to be the layer idea, which is why I times length times width times 4 in order to get 448. 2D, I said that it was possible, but the full area of the box will not be covered with wrapping paper. So if we were to put, let's see, this, if we were to make, what does it say? Put less wrapping paper where it was found, part B, part 4. So, okay, so yeah. So the volume was 448, which is greater than the 400, which was our surface area from 2B. Again, it will not be fully covered, but it is possible. And then this. For 3A, which is right here, I knew that one of our cubes that we use on our graphing paper is 1. So 1 by 1 is where I got the 12 feet by 12 feet in order to show 1 square foot, because I know that's how we count it on our on our graphing paper. For 3B, in our conversion is 3 feet equals 1 yard, or 1 yard equals 3 feet, however you want to say it. I looked a little bit more into this. I divided 12 by 3 to get 4, which is the 4 yards. I also found a little pattern. I said it goes by an increment of 3 each time. So 1 yard is 3 feet. And then when it becomes 2 yards, it's 6 feet. And then 3 yards is 9 feet, and 4 yards is 12 feet. So I went all the way up to 12 because that is what was given. It was 12 feet by 12 feet. And I knew that 1 yard or 4 yards would equal 12 feet because 3 feet equals 1 yard. So over here I drew the box, which again, this would be 16 yards squared, just because 1, 2, 3, 4, 1, 2, 3, 4. You multiply those two to get 16 yards squared. And then for 4A, I assumed that it would be the same volume because the amount of cubic meters will fit in one container, which again, volume is what can fit inside. So whatever can fit inside is the amount of cubic meters that would fit into that product container. And then for 4B, I said it would also be the same because it will cover all of the areas individually. So I noticed that 4 times 6 equals 24. And in question B, it asks for 4 individual 6 cubic meters. So if you wrap them all individually and still get 24 cubic meters, it will all be the same.